So we're here today to talk about the topics of scale and scalability, specifically for asset performance management platforms in the context of renewable energy for asset owners and service providers. One of the reasons I joined PowerFactors initially was I saw a natural ceiling to the use of traditional approaches to data systems. And obviously the allure of cloud technologies has really paid off. Maybe digging a little deeper, Abhilash, we can talk a little bit about how we address issues of data trust specifically through our products.
If you're a typical owner or asset manager today, you really have to look yourself in the mirror and ask yourself, what is your life like today? And do you honestly think that in 2 or 3 years, when you have another 2, 3, 5, 10 more gigawatts in your portfolio, is this actually going to last? And you have to ask yourself that question, whether it's processes or tools, your technology, and even just what costs you're paying, right? So when it comes to data trust, we have a crazy situation right now where some of the smartest minds, and this goes across the board, this is an industry-wide problem. Some of the smartest minds in renewables are spending their quality time basically reconciling data or fixing data issues. And this has to do with whether data is trustworthy or whether data is actually being made available to them at the right time and in the right format. And what's interesting is that, this is a problem that has been known for a while. The problem is easy to state, but answering it is a whole other ballgame. So, really what you're trying to do here is you got to visualize this for a second. An operator in Chile who's working on site or close to the site might be interacting with events or alerts or data in a certain way, but the asset manager might be living in London, or the analyst might be somewhere in the Americas. And they don't have the luxury of having to send each other a whole bunch of different communications in order to make sure that the data points they're looking at are all consistent. Something that is touched by the operator in Chile must impact the KPI that is used by the asset manager living in the Americas or living in Europe or wherever else, right? And this is, I'm using this just as an example so that we can understand what's really at stake here. Because when you multiply this problem by hundreds, thousands of gigawatts, you get to the point where you realize, we're really at a breaking point from a technology standpoint, and we have to innovate to solve this. Another great example, and this is asset class specific to make it even more interesting, right? So how you solve data issues in battery storage is different from what the data infrastructure is in solar, and is different from, so you really need to bring together subject matter expertise, decades of renewables knowledge, and modern cloud computing, modern technology in order to actually solve this problem. Otherwise, you're looking right down the barrel of spending millions of dollars unnecessarily from a technology standpoint. And not only that, actually burning out your teams trying to reconcile data issues.
And along those lines, Russ, maybe you can elaborate a little bit on some of the technical systems involved with delivering data trust.
Sure. We talk a lot about data trust and data quality, and it's, in my earlier comments, I laid the groundwork for how we're ingesting data and how we're hosting it and processing it really fast. But, as Abhilash was suggesting, really the hard part is getting that data cleansed and trustworthy. It's inherently noisy data. It takes lots of advanced algorithms and expertise to really, craft that into data that you can trust and depend on. And that's an area we're super focused on. One of the things at the heart of that are our calculation engines. And the interesting thing about calculations, you got two ends of the spectrum. One end of the spectrum, you got things that need to be calculated very fast in a streaming mode. So streaming data, fast, rapid calculations, super low latency, producing outputs. On the other end, you've got these more advanced calculations that think about analytical KPIs, things that maybe require a little bit wider view of data, multiple data points. Maybe they're a little less urgent to produce on the fly, but they're much more complex and they're harder to handle. So one thing we've learned over time is that one size doesn't fit all. You've got to have sort of multiple engine capabilities to be able to handle those extremes of processing. So we have a multi-calculation engine architecture. We support those two engines today, but who knows, there might be needs for other specialized engines in the future. And that's all stuff that's built into our architecture. So we can choose the right kind of engine for the job that's at hand. Another area that is kind of tied much to this is really customization. Being able to take the things that we give out of the box, but then to tailor those to the needs of your particular business. And so a lot of focus is going into making these things very customizable as much as possible without writing code, but rather configuring and clicking your way to tuning the outcomes that you want. So calculation engines, all this stuff is very central to our solutions as we go forward, and we're moving a lot of our workloads over to these new engines. One final thing I would mention is, just around how we store all this information. And we've got a multi-tiered historian, which basically manages all the complexity of very hot, warm, and cold types of storage. We store data, from a long period of time, and obviously there's massive amounts of it every day. And that historian handles a lot of the complexity of data delivery, both to our systems as well as outside to the systems of our customers. We know this data has to feed a lot of other purposes inside of the business. And so we've got methods for real-time, API types of access to very immediate types of data, as well as work we're doing for bulk extract and bulk access to larger amounts of that information. So that data can be there for customers where they need it to consume, for other purposes.
It reminds me a lot of, when you think about like a search engine, right? Like Google. For the last 20 years, give or take, what they've done is pretty much the same thing, right? Like you've signed on, and then you search for something and it provides the information that you're looking for. Behind the scenes, however, that engine has gotten stronger, faster, better every single day. Because think about, 10 years ago, how much data was in the internet versus now, right? And they couldn't, it's the same milliseconds in which your results come back to you, but what needs to be handled behind the scenes is so much bigger. And that's kind of what we're facing right now, right? When you look at battery storage, when you look at some of these other industries, there's so much data that's coming at you, and the size of the fleets is so much that it's really an existential question to be able to make sure it's not going to take you days just to do your basic business processes.
Yeah, I think a good illustrative example is storage warranties. Some of the OEMs require these massive data sets and long duration intervals to support the warranties, and it's not practical to store that in the same way that you would store data that you want to trend really quickly.
Absolutely.
The costs start to blow up.
Absolutely. And this is somewhere where, I think some of the customers that we're working with, some of the more savvy IT teams are aware of this, where, they come to the table, and some of the earlier questions you're asking is, what kind of databases do you use, to Russ's point, right? How are you managing, if I were to 10x or 20x or 100x the data, what is it going to cost? Is that going to mean a 10x, 20x, 100x increase in costs for us, or how are we scaling against that?
Yeah, you can see there's so many dimensions for us to optimize along.